Hello, good afternoon students. How are you all? This is Suresh, Faculty of Chemistry from Infinity Learn. Welcome to Infinity Learn NEET YouTube channel. How are you all, my dear students? Hi. Good afternoon. I'm fine, thank you. Good to see you all guys. Annamani is there online, right? So today's topic of interest is going to be chemical thermodynamics. So it's a very important topic. Before going for this important topic, I just want to say this Infinity Learn is offering NEET based, NCERT based NEET questions and NEET concepts. So you all link to this YouTube channel and please like and share and subscribe so that you will be getting all updates about this when the lectures are going to be happen, right? Right, so students are slowly gathering. Yes, good to see that. Okay, so today's topic of interest is going to be chemical thermodynamics. This chemical thermodynamics is very important as far as NEET examination is concerned. Today we are going to discuss almost all NCERT kind of definition based orientations and how the questions can be asked on that, you know. And also I am going to tell you one thing. Especially for this chemical thermodynamics, you can crack a question based on a definition. So that सारे के सारे definitions आपको अभी इसी वक्त में देना चाहता हूँ. I can guarantee you that you are going to expect one question 4 marks के लिए NEET examination से एक chemical thermodynamics से. Are you ready? Please give me a thumbs up and fire emoji in the chat box. So without any late, let's prolong this with chemical thermodynamics. What is all about it? So chemical thermodynamics here, what is a thermochemical equation and all? So heat changes during a chemical change. So chemical change means a reactant is converted into its product. Hi, Tony Stark, Iron Man, how are you? Right, good. And so we are going to see the heat changes during a chemical reaction. So during the transformation of the reactant and the product. So what happens on the reactant? So reactant में पुराना bond है, ये जो bond पुराना के है तोड़ना पड़ता है पहले. So जब reactant product बनने के वक्त में ये नया bond form करना है. So whenever the new bonds are formed, so how much energy is transformed? The energy can be given out or the energy can be taken in. है ना बेटा? So let's see how this happens. That is explained on the basis of thermochemical equation. ये thermochemical equation है क्या नया वाला है क्या? नहीं, ये बिल्कुल हमारा जो stoichiometry equation है. ये जो stoichiometric balanced equation में हर state दिखाना पड़ता है. अगर allotropic फॉर्म है वो भी दिखाना पड़ता है. एंड जितना इलेक्ट्रॉन लूज किया और जितना इलेक्ट्रॉन गेन किया वो वाला इंक्लूड करने का जो केमिकल रिएक्शन है, दैट इज व्हाट यू कॉल इट एज thermochemical equation. A chemical equation which gives all the information like energy, changes associated with a chemical reaction, Tony Stark, and also phase of various reactants and the products is called thermochemical equation. First of all, the thermochemical equation should be balanced. All the physical states should be included. If any allotropic form or any state is changing, that is also mentioned करना पड़ता है. And also finally, it is energy. Yeah. Rangrange. Hi. Hello. So let us go ahead the various types of thermochemical equations, and you have two types of thermochemical equation: endothermic reaction and exothermic reaction. So endothermic reaction is the reaction where energy is lost, and endothermic reactions where the energy is gained, and exothermic reaction is where energy is lost. So I just want to say, let us say a reactant A is combined with some amount, this is endothermic, x kilojoules of heat, and it is going to give its product B. This is what you call it as endothermic. This can also be written as A gives rise to B, and thermodynamic in the system enthalpy is going to be increased, so that it is going to be plus X kilojoules. So this is the actual version of the endothermic reaction. So I am a chemistry faculty, so that I can tell you how to prepare chemistry from the NCERT. So whatever whatever you do from the NCERT, beta, you do basic definitions and the formulas all in text and out text questions, and these questions that you solve from the NCERT, it is connected to kind of a framing like multiple choice questions. So there are certain topics you never and ever take a risk for this NCERT based, like biomolecules, you can say chemistry in everyday life, and you can say all inorganic topics and organic topics, and physical chemistry you may take a risk out of the NCERT. Okay, that is all about NCERT, and you please read line by line, don't by heart that line, and when you read that line want to say something, you try to understand and you just try to analyze that, right? Yeah, thank you very much, God bless you. Let us follow here. Let us talk about exothermic reaction. Exothermic reaction means, let us say the same reaction or the other reaction you can take. So A is giving rise to B, and along with X kilojoules of energy is lost in this example. You can write this as A gives rise to B, and enthalpy change for this reaction is, you see it is lost, so system enthalpy is going to be decreased, so that it is minus X kilojoules. What I mean to say, enthalpy of the reactant and enthalpy of the product. If the graphical way, you can also show that enthalpy versus reaction progress. So enthalpy, endothermic reaction, enthalpy of the reactant, and there is an increase for the enthalpy of the product, so that delta H is going to be positive. So this is endothermic reaction, my dear children. And when you talk about enthalpy versus the reaction progress, so enthalpy of the reactant is decreasing during this process to form the product, so enthalpy of the product is less and enthalpy of the reactant is more, so that it is going to be loss process. That is what you can say, enthalpy is going to be negative. This is an exothermic process. If you have any doubt, you please put your doubt in the comment box in the chart, so that we can discuss with that. Hannah, right? So let's see one more. In the endothermic and exothermic, what is this delta H, enthalpy change, and how it is connected to this internal energy? Everything we are going to discuss. Stay tuned, and don't hesitate to ask any kind of doubt that you have. Okay, come on dear children, I want to say, for a chemical reaction, enthalpy of reaction is equal to the difference between the sum of the enthalpies of the products minus sum of the enthalpies of the reactants. Agar enthalpy of the reaction is positive, endothermic, enthalpy of the reaction is negative, that is exothermic. In that, the change in enthalpy during a chemical process occurs due to old bonds are broken and new bonds are established. So there is a chemical bond phenomena that is called bond energy, makes the and drives the entire process. है ना बेटा? Right. So that is given as enthalpy change is equal to internal energy change plus delta nRT. That is the relation between internal energy and enthalpy. So if you talk about this, what is delta Ng? Somebody please say what is delta Ng? I am expecting some answer from you guys. Come on. What is delta Ng? Okay, Tony Stark, what is delta Ng? Here delta Ng is going to be the sum of the number of moles of the gases products minus sum of the number of moles of the gases reactants. So this is very very important, my dear students. It is given in the NCERT. हमारा तेजा, yes, हमारा एक क्लास में NCERT से हर लाइन डिस्कस किया जाएगा एंड ए पॉइंट का ही हिसाब से आपका कुछ क्वेश्चंस भी डिस्कस किया जाएगा. स्टे ट्यून्ड. And this is the trap actually. Whenever the students goes for the examination, you simply take, yes, difference between the number of gaseous molecules of the products minus reactant. Yes, Shivakanta, doubt, you please, every doubt related to the correct context is going to be honored in this class. Okay. So whenever the reaction is seen, students blindly go into the number of products minus number of reactants, which is not actually correct. You have to consider only the gaseous systems. If it is a reactant or the product is in the liquid system or in a solid system, you need not have to consider that. So Shivkanta, what is your doubt? What is your doubt? Come on. Now अगर डेल्टा एन जी मान लो ये जी जीरो होगा, डेल्टा एन जी is 0, अगर डेल्टा एन जी is greater than 0, अगर डेल्टा एन जी is less than 0, so क्या क्या चीज़ करना चाहता हूँ. So if this value is 0 and these are going to be equal, है कि ना, so that it is delta H is equal to delta U, है ना. Yes, if delta Ng ये greater than 0 तो ये वाला इससे बड़ा होना चाहिए. So delta H is greater than delta U. अगर delta H is, delta N is less than 0, delta H is going to be delta U, internal energy. Okay. So Rangresh, any doubt? You please welcome to answer. Yes, any doubt you please ask me. So could you give me an example for this? Somebody, just for the sake of your satisfaction, I just want to give a kind of example here. मान लो hydrogen is a gas combined with iodine is a gas and gives rise to Hi, where delta N G is equal to 0, है ना बेटा. And delta N greater than 0, इसका PCl5 decomposes, which is in the gaseous state, gives rise PCl3, which is in the gaseous state, plus Cl2, which is in the gaseous state. Delta N is going to be plus 1 होना चाहिए. Somebody tell me what about this N2 plus 3H2 and gives rise to NH3, and it is going to be gas and it is going to be gas. And could you tell me delta N value ये reaction का कितना होगा? Somebody, if anybody is there, okay, I want to see in the chat box. Rangresh, Tony Stark, Shivakanta, Teja, could you please tell me what is the delta N value for this? What is the delta N value for this? Make it fast. Fadafat. I am waiting for that. I am going to give lot of applause and you are going to get surprise gifts also. What is the surprise gift? Come on. Dear students, you please check in the comment box and in the description box some links are being given. You please click onto that link so that you will be getting a Telegram link. We are in the social media link. We are going to see all the links. Okay, once you subscribe, every update you are going to get. So ये reaction का यहाँ पर 4 moles था, यहाँ पर सिर्फ 2 moles क्या है. डेल्टा एन इज इक्वल टू यहाँ पर 2 minus 4 is equal to minus 2, है ना? Clear? Now I just want to say one more example. You please tell me delta. Yes, Shivakanta, you can see C plus O2 gives rise CO, which is in the gas. इसका डेल्टा एन कितना होगा? I want to see the students should be active in the class. इसका डेल्टा वन आता है आपका 2 minus 1 is equal to plus 1. कैसे? ये सॉलिड का है ना, इसका वैल्यू 0 लेना चाहता है ना, सॉलिड के हिसाब से इसका वैल्यू 0 होगा. ठीक है शिवान, you have any doubt? Okay, let's talk about enthalpy of reactions. So what is enthalpy of reaction? Enthalpy of reaction is the change in the enthalpy when all the reactants are completely transformed into its products. Nausea, it is minus 94. किस चीज के लिए नाजिया आप लिखा? Okay, so enthalpy change can be calculated for all reactions and sometimes called heat of reaction or enthalpy of reaction. This enthalpy of reaction, आपका जो reaction दिया हुआ जैसे ये reaction का हिसाब से सारे के सारा reactant product बनने का ये तरीका होता है ना, ये process में जितना enthalpy change है उसका reaction का इतना ही enthalpy of reaction बोलना चाहिए. And I want to say enthalpy of reaction, ये reaction mention करने का हिसाब से, okay, as the reaction is mentioned, according to the mentioned reaction, entire reactants are converted into products, and that enthalpy change or heat change is called as heat of reaction or enthalpy of reaction. That can be endothermic or that can be exothermic, है ना? So this enthalpy of reaction, मान लो ये reaction जैसे combustion reaction होगा, neutralization reaction होगा, formation reaction होगा, जो भी reaction मानना, and that is what you call it as enthalpy of a reaction. It all depends upon the type of reaction. So this enthalpy of reaction is further classified as enthalpy of formation. What is the meaning of the formation? So it is the enthalpy change when 1 mole of these substance is formed from its constituent elemental substances. So एक चीज याद रखना इसका हिसाब से ये रिएक्शन, ये प्रोडक्ट बनने के लिए ये एलिमेंटल सब्सटेंस से आना पड़ता है ना? So that I just want to say carbon dioxide is formed. Okay, so carbon plus oxygen. So a process में carbon dioxide is formed from carbon is an elemental substance, oxygen is an elemental substance. मान लो ये वाला carbon is the graphite state and it is in the gaseous state, okay, and this is the enthalpy of formation of carbon dioxide. ये reaction आपको दिखाई दे रहे हैं, ये enthalpy of formation of carbon dioxide पूछते हैं. If you want to take carbon dioxide, okay, like calcium carbonate, heating decompose करने तो ये solid है and gives rise calcium oxide which is a solid है and a carbon dioxide which is a gas है. ये reaction enthalpy of formation नहीं बोल सकते क्योंकि this carbon dioxide is not forming from the element, it is forming from the compound. Understand? Clear? This you can say as enthalpy of formation. And एक खतरनाक ट्रिक आपको देना चाहता हूं मैं. So enthalpy of formation of any elemental substance is going to be 0 and that value will not be given in the examination. आप याद रखना, 0 याद रखने को क्या चीज है ना नाजिया. नाउ मैं क्या बोलना चाहता हूं, enthalpy of oxygen gas is 0. Enthalpy of formation of carbon graphite is 0. Enthalpy of formation of bromine liquid is 0. Enthalpy of formation of H plus aqueous is 0. Enthalpy of white phosphorus is 0. Enthalpy of rhombic sulfur is 0, है ना. And tell me enthalpy of diamond 0 होगा नहीं होगा. Comment box, Nazia, Shivakanta, okay, Rangrej, Teja, Anamani, Tony Stark, come on, could you tell me enthalpy of reaction, enthalpy of formation of a diamond. You may feel that diamond is hard, so it is stable. No. Diamond is not, it is hard, physically hard, but as far as the chemistry is concerned, thermodynamically the stable form of allotrope is going to be graphite, right? Mind it. Diamond का नहीं है. Okay, so that makes a difference. Enthalpy of the formation of carbon dioxide from the graphite is different. Enthalpy of formation of carbon dioxide from the diamond is going to be different, right? So, and also enthalpy of combustion. So, what is the meaning of combustion? Can somebody tell me what is the meaning of combustion, my dear children? I am telling you, today's class is all about recapture of the line by line from the thermodynamics. ठीक है? Are you ready? Okay. So enthalpy of combustion. Combustion जो process है, burning होता है, जलना है, and it is the heat released when 1 mole of a substance is completely combusted or completely burned in excess of oxygen is called as enthalpy of combustion. This enthalpy of combustion हमेशा exothermic होगा, हमेशा, always, never, whatsoever the condition. So when methane is subjected for combustion, gives rise carbon dioxide and water, and 890 kilojoules of heat is released during this process. So this process, what you can say, it is enthalpy of combustion. So enthalpy of combustion gives a lot of valuable information. So you can say enthalpy here. So enthalpy of reaction can be given as sum of the enthalpy of the combustion of the products minus sum of the enthalpy of combustion of the reactants. So this kind of always a product minus reactant. So from there, combustion process is easy in the chemistry laboratory, so that you can take certain amount of substance and you can go for the combustion. So that combustion process can give you the appropriate thermodynamic data for you, and it is easy to analyze it. Right. So children, if you have any doubt, please don't hesitate to ask any doubts. Tony Stark and Nazia, Shivakanta and Rangresh, Annamani, and all any students are online, you just experience the awesome lectures that are being delivered from Infinity Land YouTube studio, and this is a live interactive session. You don't have to hesitate, you can discuss with me any kind of discussions. As far as this topic is concerned, we are going to get the doubt get resolved here. If you are not able to join the class during a live session is going on, you please watch the recording and you can experience the awesome lecture. If you have still any doubt, you can mention in the comment box so that the doubt is going to be resolved like anything. है ना? So आगे बढ़ता हूँ, and after enthalpy of combustion we can go for enthalpy of solution. ये बहुत important बात है. एंड 2-3 बार एंथैल्पी ऑफ सॉल्यूशन का हिसाब से क्वेश्चन भी पूछा गया इन नीट एग्जामिनेशन में और वॉट एवर द कॉम्पिटिटिव एग्जामिनेशंस में भी. It is the heat released or absorbed when 1 mole of an ionic compound is dissolved in excess of solvent. Solvents is generally in the water. And why I am telling this one is a little confusing. अरे enthalpy of solution अलग होता है, enthalpy of hydration अलग होता है. So I just want to say magnesium sulfate is a solid put in a large excess of water, so that you are going to get a magnesium 2 plus and SO4 2 minus. It is getting ionized and it is hydrated, and during this process some amount of the heat is released, that is a enthalpy of solution. Okay, enthalpy of solution. And what to say enthalpy of solution, after that immediately I just want to say enthalpy of hydration. Enthalpy of hydration. If it is a standard state, that is called standard enthalpy of hydration. What is the standard state in thermodynamics? 298 Kelvin, 1 atm pressure is called as standard states in thermodynamics. Hey, na? And I just want to say it is the energy released or absorbed when 1 mole of anhydrous or partial hydrated salt undergo hydration by the addition of water of crystallization. I mean to say CuSO4 plus 5H2 gives rise to CuSO4 dot 5H2, and it is said to be enthalpy of hydration. Okay, and it is the amount it can be released. So hydration, water of crystallization tak diya. In chemical bonding you can learn this as enthalpy of hydration for the dissolution process. For that dissolution process, the amount of energy that is liberated when 1 mole of the gaseous ion is completely hydrated. Okay, so that we can see enthalpy of neutralization. My dear students, from the NCERT you can see you are capturing each and every point as far as the enthalpy of enthalpies of various processes are concerned. In this session we are taking every line into the NCERT into account. Right now, in this case, enthalpy of neutralization, the enthalpy change that occur when one equivalent of an acid is completely neutralized by an equivalent of base and in the large dilute solutions. That is what you say. The heat released or absorbed when one equivalent of an acid undergo complete neutralization with one equivalent of a base. Okay, it is released, not absorbed. Generally it never absorbs, it is releases, and it is going to be when H plus in dilute solutions plus OH minus in the dilute solutions gives rise H2O, and this enthalpy of reaction, हर चीज enthalpy of reaction होगा, इसी वक्त में this is called enthalpy of neutralization, that is going to be 57.3 kilojoules. You have to memorize this value. You have to memorize this value. ठीक है? Any doubt, children? Hope you are enjoying all kinds of definitions. Not only defining all kinds of definition, my dear students, we are going to do some questions as far as these concepts are concerned. Yes, आगे बढ़ते हैं. Enthalpy of neutralization. Always remember enthalpy of neutralization between a strong acid and a strong base. Strong acid से a strong base से आना पड़ता है, तभी ये value 57.3 is the value. But if the weak acid plus weak base, or weak acid plus strong base and weak base plus strong acid, so what is the scenario? It is less than minus 57.3 kilojoules. Why it is less than this? If anybody knows, you please let me know why it is less than this. Why it is less than this? Because that weak acid or weak base, it has to ionize. ये आयनाइज करने के बाद ये न्यूट्रलाइज करना पड़ता. ये आयनाइजेशन प्रोसेस में कुछ एनर्जी इस्तेमाल किया जाएगा. Therefore that value is coming down. है ना? Clear? Doubt है. Okay, Tejas, very good. Rangrej, Annamani, Tony Stark, Najia, very good. Now let us go ahead for this. Now let us talk about Hess law of constant heat of summation. So anybody knows about the Hess law? Kabhi suna hai kya? Arey, it is there. Total thermochemistry is based on Hess law of constant heat of summation. ओके ये क्या बोलना चाहता हूँ, ये हेस लॉ ऑफ कांस्टेंट हीट ऑफ समेशन. मान लो ये रिएक्टेंट ये गिव्स राइज टू डी, it assumes to have, let us say, Q1, Q is the heat. In the other way, this A is indirectly giving to B and B is giving to C, C is giving to D, and this is going to be Q1 heat and this is going to be Q2 heat and this is going to be Q3 heat. है ना? Yes. Now what this Hess law want to say? The reaction is taking place in a single step, A to D. The reaction is taking place in A to B and B to C and C to D. It is taking place. Nazia, you please ask your doubt, please. You are always welcome. So when the reaction is taking place in a single step or in a multiple steps, the heat of the reaction, yes, Nazia, yes, please, you can ask a doubt. You can post your doubt in the chat box. So the reaction takes place in a single step or in a several step, the heat content is going to be constant. I just want to say, ये जो Q है ना, is equal to sum of Q1 plus Q2 and plus Q3. So this is what you can say, it is a Hess law of constant heat of summation. So it says that the reaction heat of a reaction is same whether the reaction takes place in a single step or in a several steps. है ना? नाजिया, आप कुछ डाउट पूछना चाहता हो पूछ सकते हैं. You are always welcome to ask any kind of doubt. Okay, Nazia, Shivakanta, Rangrej, Teja, Tony Stark, Annamani, all there in the class. Okay, near about 487 students are there in the class right now on live. So students, take advantage of this. You please like this session and share with your friends. So इन लोगों को भी फायदा होना चाहिए. And subscribe to the channel so that आपको जो classes का schedule है, okay, आपका बेल बटन में दबाओ, आपका अपडेट मिलते जाएगी. एंड आल्सो यू आर गोइंग टू गेट सारे के सारे नोट्स PDF फॉर्म में मिलेगा. टेलीग्राम चैनल में ज्वाइन करने का कोशिश करो माय डियर चिल्ड्रेन, है ना? सो आगे बढ़ते हैं बॉर्न हैबर साइकिल का. व्हाट इज अ बॉर्न हैबर साइकिल? ओके, हाँ नाजिया, कुछ डाउट है और कुछ डाउट नहीं है? Okay, let's talk about, आगे बढ़ते हैं. Born Haber cycle, it's a nightmare. Students, it is a nightmare. Definitely, if you have any kind of difficult question, very important question, मान लो ये Born Haber cycle ionic bond का हिसाब से भी आ सकते हैं and chemical bond में and thermodynamics में भी है. So that आपका डबल फायदा है. हमारा ये क्लास में I am going to explain you the Born Haber cycle. So you never and ever please don't memorize any value, rather you memorize only the phenomenal facts. So accept that enthalpy of neutralization. है ना बेटा? Get ready for that. Okay. So let's see Born Haber cycle. In this Born Haber cycle, I just want to take sodium chloride, formation of a sodium chloride. So it is used to calculate the bond lattice energy. What is the meaning of a lattice energy? Lattice energy is the energy that is liberated when 1 mole of ionic solid is formed from its constituent gaseous ions is called ion lattice energy. Lattice का मतलब क्या? आयोनिक क्रिस्टल. जब 1 मोल आयोनिक क्रिस्टल फॉर्म करने के लिए कहाँ से करना है? ये आयोनिक कंपाउंड का जो आयन से गैस स्टेट में होना चाहिए, ये आयन्स से एक आयोनिक सॉलिड बनता है ना, उसी प्रोसेस में कुछ एनर्जी निकलते हैं, एंड दैट एनर्जी यू कैन से इट इज अ लैटिस एनर्जी. सो ये लैटिस एनर्जी जो है ना, ये डायरेक्ट स्टेप में कैलकुलेट नहीं कर सकते, लेकिन ये इनडायरेक्ट स्टेप में हेस लॉ ऑफ कांस्टेंट हीट ऑफ समेशन का हिसाब से आप कर सकते हैं. मैं आपको दिखाने वाला. सो यू कैन से सोडियम, which is a solid combined with half Cl2, which is a gas, and it is going to give you sodium chloride, which is a solid. So this is what you call it as enthalpy of formation of sodium chloride. It is for enthalpy of formation of sodium chloride. So you can say this energy, you can say enthalpy of formation of sodium chloride. And also I just want to take indirect steps. जो indirect steps आते हैं ना, देखो point to point, हर point आपको देना चाहता हूँ. So sodium is solid is converted into sodium in the gas state. This process you can say it is a sublimation process. ये sublimation process में solid directly converted into the gas. So I just want to say enthalpy of sublimation, that you can say enthalpy of sublimation, yes, stands for sublimation. And also you can take this as chlorine dissociate to gives rise chlorine gas, that is what you call it as enthalpy of atomization. This is what you call it as enthalpy of atomization. 1 mole का 1 chlorine mole का है. हाँ, Shivansh, why you are not coming regularly? कहा मैं कैसे बढ़िया, मैं बढ़िया, आप कैसे? So we are all developing with Shivans, and I just want to take this in a different way, raising with Shivans. Shivans developed a lot with YouTube channels. Every time he attend my classes, and he developed a lot. है क्या ना? Yeah. Stream change तो हो गया क्यों? So अगर आप सोडियम जो गैसेस स्टेट में है, it is going to give you sodium plus and chlorine hai, and this require enthalpy of ionization, enthalpy of ionization. Huh. Okay, now you can say chlorine which is in the gas state, इसका एक इलेक्ट्रॉन ऐड करने के बाद क्या होगा, इसका के इलेक्ट्रॉन ऐड करने के बाद क्या होगा, क्लोरीन माइनस बनेगा, so that which is in the gas state. So I just want to say that is what you can say enthalpy of electron affinity, electron affinity. Okay, so मान लो ये वाला जो है ये प्लस वैल्यू का है, इलेक्ट्रॉन देने का है, ये इलेक्ट्रॉन देने का है, ये इलेक्ट्रॉन निकालना का है ना, एंड उसमें क्लोराइड माइनस है, दिस क्लोराइड माइनस एंड Na प्लस दोनों मिला के आपका सोडियम क्लोराइड बनना है. सो ये सोडियम क्लोराइड एक गैसेस आयन से बनने का वक्त में आपका आएगा, दैट इज व्हाट यू कॉल इट एज लैटिस एनर्जी. दिस इज व्हाट यू कॉल इट एज लैटिस एनर्जी. This lattice energy is going to be negative. This lattice energy is going to be negative, है ना? This negative. And let us talk about the total process. This lattice energy can be calculated by using Hess law of constant heat of summation job. So cycle है ना, that cyclic thing is what do you call it as Born-Haber cycle. ठीक है. So delta HF, that is delta HF is equal to पहला delta HS enthalpy of sublimation plus enthalpy of atomization by 2 y by 2. एक मोल का enthalpy of atomization होगा, हाफ मोल आपको चाहिए. सो जो वैल्यू है उसमें आधा लेना चाहता हूं मैं. एंड इट इज गोइंग टू बी एंथैल्पी ऑफ आयनाइजेशन माइनस एंथैल्पी ऑफ इलेक्ट्रॉन गेन, इलेक्ट्रॉन अफिनिटी यू कैन से, माइनस एंथैल्पी ऑफ लैटिस. So you can be given, this is the algorithm. My dear children, ये algorithm का हिसाब से जो भी वैल्यू है ये क्वेश्चन में दे सकता हूँ. और the value which is video is visible to you guys. You please confirm in the chat box. Please confirm in the chat box. Please confirm in the chat box. Okay. Now let us go ahead. Now bond dissociation energy. So actually when the bond is formed, the energy is released. When the bond is broken, energy is taken in. So you require energy to break a bond, and when the bond is formed, the energy is released. So for bond formation is exothermic and bond breaking is endothermic. Okay. So the energy needed to break the bonds of 1 mole of molecule is called bond dissociation energy of the substance. It is defined as per mole of the molecule, है ना? So if it is a diatomic molecule, bond dissociation energy is equal to enthalpy of atomization, whereas in the polyatomic molecule, bond dissociation energy has to be taken as the average. So enthalpy change in the reaction, delta H is equal to sum of the enthalpy changes for the bond broken minus sum of the enthalpy of the reaction when the bond is formed, है ना? That's good. Now आगे बढ़ना है थोड़ा. So bond dissociation enthalpy, and here I just want to say in the bond dissociation energy should be taken, it is in the form of average. I just want to say carbon, hydrogen and hydrogen and hydrogen and hydrogen. If the 4 bonds are broken, for this bond broken you require A kilojoules of energy. For this bond you require B kilojoules of energy. For this bond you require C kilojoules of energy. For this bond you require D kilojoules of energy. है ना? A, B, C, D. So the average, okay, the average carbon to hydrogen bond energy. Don't say A, B, C, D are equal. No. They are not at all equal. Once the bond is broken, the other is going to change its value. So the average carbon to hydrogen bond is going to be A value plus B value plus C value plus D value by 4. Like that you need to take the average, and this kind of calculations are very important. We are here and discussing each and every point from the NCERT. You just unnecessarily you just go into the trauma like you open a big book and you are doing जितना बड़ा बुक कर रहे हैं ना ये उतना मेहनत कर रहे हैं, that is wrong assumption. And just open NCERT book, लाइन से लाइन बाय लाइन आप पकड़ लो, अच्छा तरफ मटेरियल पकड़ के जो भी आपका कोचिंग इंस्टीट्यूट होगा, and you can go for the IL ranker series book prize, Sri Chaitanya Infinity Learn, and you can do good number of quality questions. आप अच्छा तरफ नीट एग्जामिनेशन में आप सीट ग्रैब कर सकते हैं and book your medical seat. Okay, that is the confidence that we can give from the Infinity Land by Sri Chaitanya. Are you ready? Are you ready for grabbing medical seat? Right. Okay, fine. Now let us talk about, this is the average bond dissociation energy, and let us go ahead with some more things, that is heat of atomization. This is nothing but dissociation. So it is defined as the energy required to convert any substance into gaseous atoms. I mean to say, here I can say chlorine gas is converted into 2 chlorine atoms. Atoms का है ना, that is called enthalpy of atomization. I can say HCl gives rise, H is a gas, Cl is a gas. You don't say H plus and Cl minus, that is not dissolved in the water, that is called dissociation. Similarly, you can say CH4 is a gas, gives rise, carbon is a gas, and 4 hydrogens are the gases. So this is what you call the bond dissociation. Hey Kinam, clear? And also you can say various things. So resonance energy, and you are going to see the resonating structures. This is your benzene, and it is going to give one more benzene structure, and actually the resonance of the benzene, this is what you call it as a resonance hybrid. And these are called resonating structures. These are the resonating structures. ये चीज में the difference between the resonance hybrid and one of the stable resonance canonical structure, जो energy अंतर होता है ना, the energy gap between these two is called as resonance energy. This resonance energy thermodynamically आप calculate कर सकते हैं ये formula के हिसाब से. This is enthalpy of formation experimental, that is actual, and the difference between enthalpy of formation that theoretically you calculate, that is what you call it as a resonance energy. जिस compound structure में resonance energy ज़्यादा है, इसका stability भी ज़्यादा होगा. So resonance energy is quite important. It is a deciding factor for many things. It is even important for your chemical bonding and the organic chemistry, even in the thermodynamics. I just want to say stability is directly proportional to resonance energy. There is no deviation in that. There is no deviation in that. ठीक है बेटा? And before going for that, I just want to conclude this session with a couple of questions. Ready with that? Ready with that? Now you are going to see, my dear students, यार मेरा हमारा सेशंस में NCERT बेस्ड लाइन बाय लाइन कॉन्सेप्ट एक बार डिस्कस करना चाहता हूं, एंड ये जो कॉन्सेप्ट डिस्कस करने के बाद आपका क्वेश्चंस कैसा निकाल सकते हैं एंड बेसिक क्वेश्चंस में भी आपका देना चाहता हूं. ठीक है, गेट रेडी. एंड इन अ रिएक्शन कार्बन डाइऑक्साइड प्लस हाइड्रोजन गिव्स rise carbon monoxide and H2O. Delta H is given as 2.8 kilojoules. This delta H जो दिया हुआ आपका क्या बोलना चाहता हूँ, that is heat of formation, and heat of a reaction and heat of a solution, heat of a combustion. यहाँ पर कुछ combustion नहीं चल रहा है, गलत बात है. There is no solution formation, गलत बात है. And heat of formation, अरे कुछ compound form नहीं कर रहे हैं elemental state से, जो भी reaction आपको जैसे दे रहा हूँ वैसे enthalpy बोलना है. That is what you call it as heat of reaction. Got it? This is the simplest version of understanding what thermodynamics tells you from the NCERT. है ना? Any doubt, dear children? Ready for that? And और एक क्वेश्चन करने का तैयार है आप? अरे चार्ट बॉक्स में आप कम से कम आंसर देना है तो हम भी खुश होगा. आपके लिए इतना मेहनत करके आप ये स्लाइड्स बना हुआ आपके लिए. राइट, वेरी गुड. नाउ लेट्स सी हियर, आंसर इज गोइंग टू बी heat of formation नहीं होगा, it is going to be heat of a reaction. Now the enthalpy change for the reaction, H2O solid gives rise H2O liquid is called. Answer फटाफट दे, आंसर फटाफट दे. Clear? And it is a solid is converted into a liquid, so it is nothing but a fusion. It is called a fusion, melting. This is what you call it as a melting. Technically it is called as a fusion. Okay, so this is what you call it as enthalpy of fusion. What is the meaning of enthalpy of vaporization? ये लिक्विड से गैस होना है. एंथैल्पी ऑफ फ्यूजन सॉलिड से लिक्विड होना है. एंथैल्पी ऑफ फॉर्मेशन आपको मैं बता चुका. एंड एंथैल्पी ऑफ ट्रांजिशन, एक फिजिकल स्टेट से एक ही सब्सटेंस एक ही स्टेट में एक एलोट्रोप से और एक एलोट्रोप तक पहुंचने के लिए, दैट इज कॉल्ड एंथैल्पी ऑफ ट्रांजिशन. है ना बेटा? गुड टू सी. And one more, which of the following pair has heat of neutralization equal to minus 57.1? Whenever a strong acid and a strong base is neutralized, its value is going to be 57.1. One equivalent of a base, one equivalent of an acid. Here it is a weak base. It's a weak base. It's a weak base. It's a weak acid. So my answer is going to be any strong acid, any strong base, it is undergoing neutralization. Strong acid क्या दे सकते हैं? H plus. Strong base क्या दे सकते हैं? OH minus, H2O. Delta H is going to be minus 57.1 kilojoules. ठीक है बेटा? Shivakanta, okay, Nazia, Shivansh, Rangrej, and one more question, my dear children. So my answer is here A. And one more question, calculate the amount of heat evolved when 500 cm cube means milliliter, of 0.1 molar HCl, hydrochloric acid, is mixed with 200 milliliters of 0.2 molar sodium hydroxide. So enthalpy of neutralization, this is connected to stoichiometry, this is connected to solutions and concentration terms, and this is connected to ionic equilibrium, this is connected to thermodynamics. So we are going all the way, not beyond NCERT textbook. So answer कौन दे सकते हैं? फटाफट. Now you can see moles of HCl, that is equal to molarity into 1000 into volume, it comes to be 0.05. Similarly, that is 200 centimeters of 200 cm cube of 2.2 molar sodium hydroxide, that contain 0.2 upon 1000 into 200, that gives you 0.04. So ये 0.05 था and 0.04 था. So उसमें ये वाला कम से कम है, so that it is a limiting reagent. So ये कम हो ना, so जो reactant ये कम है, ये वाला limiting reagent होगा. So that heat evolved for 1 mole is going to be 57.1 kilojoules. If it is for 1 mole 57.1, if it is for 0.04 mole 57.1 into 0.04 is going to be 2.284 is the answer. 2.284, option A is the correct answer for this question. It is the simplest it is the simplest way of doing thermodynamics, thermochemical equation based questions. Okay, we'll do one more. Get ready, and here calculate the enthalpy change accompanying from the graphite and converted into diamond. Here given that enthalpy of combustion of graphite. So जब graphite combustion करना है ना, so it becomes carbon dioxide. The enthalpy of combustion minus 393.5 दिया, it is given. जब डायमंड कंबशन कर रहे हैं ना, इसका वैल्यू थोड़ा सा अलग आ रहे हैं. So that what I want to say, we aim to convert graphite to diamond. Let us use how to get graphite to diamond. So graphite is there in the reactant side. ये पहला जो रिएक्शन है, C graphite plus O2 gives rise to CO2. So I want diamond in the product side, so that I just want to say it is minus 393.5 and this is CO2 gives rise C diamond plus oxygen. So it gives rise to minus 395.4. Now if you add these, what you are going to get here, CO2 and CO2 and दोनों मिलके C graphite is converted into C diamond. उसमें oxygen and oxygen also get cancelled. So when you say sum this number, when you take this number, it is going to be plus 1.9 kilojoule is going to be. So you have to give 1.9 kilojoule per mole. इतना ज़्यादा energy चाहिए. That is the reason why graphite is converted into diamond by Hutchinson method. So this is the thermodynamic phenomena that you can make diamond. It is not possible at home. You require a big furnace for that. Okay. So this question is based on thermodynamics phase transitions. और एक चीज़ है, calculate the enthalpy of hydration of anhydrous copper sulfate is hydrated, so to form copper sulfate pentahydrate. So that you can say this, given that enthalpy of solutions of anhydrous copper sulfate and hydrated copper sulfates are given 66 and 11.7. So copper sulfate pentahydrate, when you put in the water, gives rise copper sulfate dissolved. So that is called enthalpy of solution. And also you can say copper sulfate in the solid aqueous, copper sulfate aqueous, enthalpy of solution, this is for H1, that is minus 66.5. That is the given data. So but I want to get copper sulfate solid plus water gives rise copper sulfate pentahydrate. We have to calculate this. So this is a very important model for thermodynamics. Dear children, for that what I have to do, ये उल्टा करना पड़ता है. So ये जो solid का है ना, ये product में बनने के लिए ये reaction 2 is reversed and added with reaction 1. So I want to say it is added means this value minus this value subtract करने, ये plus minus बनेगा उल्टा होने तो. So आपका मिलेगा 78.2 is the answer. 78.2 is going to be the answer. Answer is going to be minus. है ना? Clear? Right. So calculate the enthalpy of formation of methane. So how do you say enthalpy of formation of methane? So methane is a gas, should be formed from carbon, it is in the diamond, plus two hydrogen molecules are combining to give rise enthalpy of formation. Yes. So who is that? Okay, come on, Shivans. So their values are methane, graphite, hydrogen are given here. Okay, so we can say that methane, O2, CO2 and H2O, combustion of methane, that is 890. So combustion of methane is 890 and combustion of graphite is 393. Combustion of graphite is 393 and combustion of hydrogen are 285. Combustion of hydrogen is 285 is given. Understand? Now what we aim to get? Carbon in the graphite plus 2H2 gives rise methane. We have to calculate what is delta H. To calculate the delta H over there, you just take this enthalpy formation of methane. So one methane should go on that other side, right? Or else you can say, in order to get this thermochemical equation, working भी लगा दिया मैं आपके लिए सिर्फ, multiply equation 3 and add to equation 2 and then subtract from the equation 1. So if you do so, आपका मिलेगा C plus H2 gives us CH2, CH4. So that delta H is going to be minus 393.4 plus 2 into minus 285.7 minus 890.2. So सब मिलके आपका मिलेगा 74.6 negative. So that 74.6 negative kilojoules of energy. So that is the answer for this question. And also थोड़ा सा आगे बढ़ के अच्छा तरफ क्वेश्चंस देना चाहता हूँ. Which of the following enthalpy is always negative? Before closing for the session, I just want to ask this question. So किसका होगा? एंथैल्पी ऑफ सॉल्यूशन कभी कभी पॉजिटिव हो सकते हैं, कभी कभी नेगेटिव हो सकते हैं, ये नहीं होगा. एंथैल्पी ऑफ कंबशन व्हेन यू सब्जेक्ट फॉर द कंबशन, हमेशा कंबस्टन पॉजिटिव होगा. एंड आल्सो एंथैल्पी ऑफ सब्लिमेशन हमेशा एंडोथर्मिक होगा, नॉट एक्सोथर्मिक. Okay, enthalpy of formation could be endothermic or exothermic. So my answer for this question is going to be option 2. So like that, today we discussed many things from the thermochemistry, line by line from the NCERT textbook, and we discussed so many things and so many NEET based questions, and you follow the same advices and same methodologies when you prepare for the NEET examination, and get ready to book your NEET seat and medical seat and through the NEET examination. Please follow our NEET Infinity Learn channel and please like this session and share with your friends, and the journey is going to be awesome. Okay, so we are done for the day. Thank you very much, and stay tuned for more updates. Okay, thank you. Signing off, Suresh Avari from Infinity Learn Studio. Thank you very much.